Let's solve this question now. Show that if n is a positive integer, then 1 plus 2 plus etc. up to n is equal to n into n plus 1 by 2. So this is the question. So you know that this comes under the chapter mathematical induction. So the problem has to be solved in 3 steps. So what is the first step called? First step is basic step. Under basic step, what we are doing here, it is for n is equal to 1. See, in the given equation, just substitute n is equal to 1. See here, this n is here at the end. So that means up to n. So here n is given as 1. So in the left hand side, what remains is only 1. So in the right hand side, you have n into n plus 1 by 2. Wherever you have n, you substitute it as 1. So 1 into 1 plus 1 by 2. Okay, so 1 plus 1 is 2. 2 cancels, so you get 1 is equal to 1. That means left hand side is equal to right hand side. This is the first step, we call it as basic step. And the second step, we call this as inductive step. In inductive step, there are two cases. First one is to take n is equal to k. So when you take n is equal to k, the equation goes like this: 1 plus 2 plus etc. up to k is equal to, wherever you have n, you write as k. So k into k plus 1 divided by 2. You name this equation as 1. Any name, you can call it as a, whatever it is. Okay, so we assume that this p of k, that is by taking n is equal to k, this is valid. So we assume that. Now what we do is, if it is applicable for n is equal to k, then it must be shown that it is true for n is equal to k plus 1 also. So n is equal to k plus 1, that is the next step. So what do we write here? 1 plus 2 plus etc. up to k plus 1. Wherever there is n, you replace it with k plus 1. But here you see, if this is k plus 1, what is previous to that? That is k. So that is equal to, in place of n, now you are writing it as k plus 1. So here k plus 1 plus 1 divided by 2. Okay. Now you see here, you can solve this. Left hand side, the same thing will be here, same thing. Here it is k plus 1 into k plus 1 plus 1 it is. So that is k plus 2 divided by 2. So actually we have to prove this. How we are proving this? We will go ahead by considering equation 1. Now if you consider this equation 1 and this equation 2, you first analyze the left hand side. In equation 1, you have up to k. In equation 2, you see what is there on the left hand side? What is extra? See, this term is extra. Correct? So what you do is, we go by the comparison method. Now let's add this k plus 1. See, what is missing in equation 1 is this k plus 1, right? So we are proving from equation 1 to equation 2. Using equation 1, by adding this k plus 1, we have to prove that the right hand side of the equation is k plus 1 into k plus 2 by 2. So this is what we are doing. Okay, step is very simple. So let's add k plus 1 to the equation 1 as mentioned. So this is 1 plus 2 plus etc. up to k is already there in equation 1. So we will add this k plus 1 to the left hand side. So on the right hand side of the equation 1, we have k into k plus 1 by 2. Okay, so this is k there, k into k plus 1 by 2. What we have to do, since we have added k plus 1 to the left hand side, we have to add the same k plus 1 to the right hand side also. So now what you get here is the common denominator is 2 here. So 2 1 times. So what is there on the left side there? K into k plus 1 plus, see here it is actually 1. So 1 2 times. So you have to multiply 2 into k plus 1. So that is k into k plus 1 plus, so that is k plus 1 is common there, so you can take it out. K plus 1 into what is remaining next? K plus 2 divided by 2. So you see this equation 2, it is same now. So from equation 1 we have obtained this equation 2. So last equation shows that P of k plus 1 is true. So this proves the what is asked to prove. Okay, you can leave it here. I hope you understood this. So the second problem is about use mathematical induction to prove the inequality n less than 2 to the power n for all positive integers n. So this problem is also solved in the class. Now same process here also. How many steps? 2 steps. Inductive step, sorry, first one is basic step, second one is inductive step. So in inductive step, 2 cases that we know. So how do we start? First, basic step. Basic step is by considering n is equal to 1. So the given equation becomes 1 less than 2 to the power 1. That means 1 less than 2. So 1 is less than 2, it is true. Okay, that is the first step, basic step. In the second one, it is inductive step. In inductive step, there are 2 cases. First one is for n is equal to k. Okay, this is, let us call it as a, n is equal to k. So what we are doing here when n is equal to k means k less than 2 to the power k. You call this as equation 1. In this, the second part is, if this is true, if n is equal to k is true, the same should be true for n is equal to k plus 1. The same type we have solved the previous problem also. So wherever there is n, you replace it with the k plus 1. So k plus 1 less than 2 to the power k plus 1. So this is equation 2. Now you see equation 1 and equation 2. See, our aim is to prove this equation 2. But to prove this equation 2, we have to start from equation 1. Now if you compare the left hand side of equation 1 and 2, what is extra in equation 2 is that plus 1. So what we will do now, the same plus 1 is missing in equation 1, right? So that we will have to add. So what you get, equation 1 is k. Okay, so for that what we have to do, you have to add this plus 1. Okay, so plus 1, when you add to the left hand side, you should also add to the right hand side also. 2 to the power k, not to the power, you have to add here, plus 1. Okay, now from this we have to go ahead. All right, so what was that? K plus 1 less than 2 to the power k plus 1. Same equation I have written. let us call this as equation 3. Now you see what we want to prove. We want to prove k plus 1 less than 2 to the power k plus 1. See, left hand side we have no problem now, k plus 1. But right hand side should be 2 to the power k plus 1. So here it is 2 to the power k plus 1 is there. So what is creating the problem is this 1. So we have to replace for that 1. So what we do is, see, we know that 1 is less than 2 to the power k for any integer where k is any integer. So this means we can say 1 is less than 2 to the power 1. In the same way, 1 is less than 2 to the power 2. 2 to the power 2 is 4. So 1 is less than 4. So 1 is less than 2 to the power 3, etc. So like this, finally we can replace this 1 by, what is that? We can generalize it, 2 to the power k. So from equation 3 you have that 1, right? So you replace that 1 with 2 to the power k. Therefore equation 3 becomes k plus 1 less than 2 to the power k plus, now 1 is to be written as 2 to the power k, okay, 2 to the power k. So that is k plus 1 less than 2 to the power k into 2 to the power k means what? 2 times 2 to the power k, correct? Okay. Now k plus 1 less than this 2 means it is 2 to the power 1 only, right? So 2 to the power 1 plus, so 2 to the power 1 plus k. Okay, so that means k plus 1 less than 2 to the power 1 plus k can also be written as k plus 1, right? So this is equation 2. This is what we wanted to prove. So how did we prove? With the help of equation 1, we proved equation 2. So this is the method. I hope you all understood this. Then you go through the notes also, then you will understand better. Alright. Now we'll move on to the next question. So this is the third question. Use mathematical induction to prove that 2 to the power n less than n factorial for every integer n with n greater than or equal to 4. Now if you analyze this problem, only when n is greater than or equal to 4, that equation 2 to the power n less than n factorial is valid. You can try for n is equal to 1, it is not valid because 2 to the power 1 is 2, less than 1 factorial means 1. So that is not applicable, isn't it? So 2 is greater than 1, here you get 2 is less than 1, which is not true. Same way for n is equal to 2 also it is not valid, n is equal to 3 also it is not valid. So it is already mentioned in the problem very clearly. So the given equation is applicable only when n is greater than or equal to 4. So this also has the same steps as we discussed earlier. So the first step is what? First step is always the basic step. So usually basic step we used to start from n is equal to 1. But here it is not possible. We have to start from n is equal to 4 because in the problem also it is mentioned given equation is valid only when n is greater than or equal to 4. So we will start from n is equal to 4. So what does it mean? You see the left hand side of the given equation 2 to the power n. So left hand side is 2 to the power n. N means how much? 4. So what is 2 to the power 4? 2 to the power 4 is 16. So what is the right hand side? Right hand side is n factorial. That means in this case it is 4 factorial. So 4 factorial means 4 into 3 into 2 into 1. So how much you get here? 4 into 3 is 12. 12 into 2 is 24. So you get here as 24, which is very clear that left hand side is less than right hand side. Correct? So this is true. Now in the second step, what are we proving? Second step is called as inductive step. So in inductive step, What we have to consider? N is equal to k. So what will be the equation when n is equal to k? Wherever there is n, you write it as k. So 2 to the power k less than k factorial. You call this as equation 1. So you know one more step in inductive step, that is, if n is equal to k, if the equation is true, it should also be applicable for n is equal to k plus 1. So if you consider n is equal to k plus 1, what you get? 2 to the power k plus 1 less than k plus 1 factorial. You call this as equation 2. Now we will have to prove this equation 2. As the previous two problems that we have worked out, from equation 1 we have to arrive at equation 2. This is what we have to prove. The method will slightly vary here. So what we will do is we will start from the left hand side of equation 2. So what is the left hand side of the equation 2? See, but we know this equation very clearly. See, equation 1 says 2 to the power k less than k factorial. Okay, that is equation 1. Already we have done it. Now the left hand side of equation 2 is, see, left hand side of equation 2 is 2 to the power k plus 1, correct? So 2 to the power k plus 1. So right hand side of equation 2 is k plus 1 factorial. So from here only we will modify. See, 2 to the power k plus 1. See, this is slightly different when compared to the previous two problems. That's what I said. Every problem has to be analyzed in a different way. Even though the basic structure remains same, the approach of solving is slightly different here. So left hand side you see 2 to the power k plus 1. So I can write this as 2 to the power k into 2 to the power 1. Okay, or you can also write this as 2 into 2 to the power k. Okay, now you see our ultimate aim is to get what? In the right hand side of this equation that we are simplifying, we should get k plus 1 factorial. Now you see, now we have 2 into 2 to the power k. From this we have to see that we get k plus 1 factorial. So how are we going to do this? Look here. Here we know very well 2 to the power k is less than k factorial. Okay, 2 to the power k is less than k factorial. So in this 2 to the power k here, this 2 to the power k we have, no? See, this 2 to the power k we will write as k factorial, but we'll use this less than symbol. 2 into k factorial. Still our problem is not solved. We want to see that the right hand side here should be k plus 1 factorial. Now what we have to do is, this 2 is creating the problem, that k factorial, let it be there, that we can do something. Now 2 can be written as, see, our ultimate aim, you should understand the logic first. Our ultimate aim is to get that k plus 1 factorial. See, you know 2 is less than k plus 1 when k is greater than or equal to 4. That we are familiar. So this 2 you replace by k plus 1 into k factorial. What is the aim? Our aim is to get k plus 1 factorial. Now we have k plus 1 into k factorial. So for which I will show you on a few equations here. See, what is 4 factorial? 4 factorial is 4 into 3 factorial. Actually 3 into 2 into 1, right? So we can write it as 3 factorial. Similarly, tell me what is 8 factorial? 8 factorial is 8 into 7 into 6 into all those. So that we can write as 7 factorial. We know that. So what is 9 factorial? 9 factorial is 9 into 8 factorial. So likewise, if you go on doing it, can you tell me what is k plus 1 factorial? k plus 1 factorial is k plus 1 into k factorial, correct? So you see here we have the same. What is this? K plus 1 into k factorial is nothing but what? K plus 1 factorial. So this is what we wanted, 2 to the power k plus 1 less than k plus 1 factorial. This is equation 2. See, we just brought the left hand side of the equation 2, that is 2 to the power k plus 1, and we arrived at right hand side, that is k plus 1 factorial. So this is how we solve this type of problem. So you refer the notes now, you will understand it very clearly. So out of these three, any one is expected. So study this thoroughly. All right.